questions, 50 points. The quiz is Tuesday, 2/25. I can convert expressions between exponential and radical. So exponential, having x to the half, and knowing that as a radical, that's the square root of x. So going back and forth between the two. I'm going to be asking you to do both of those. There's 8 questions, 4 each, for a total of 24 points. So about half the test or quiz is going to be switching back and forth between exponential form and radical form. The second half of your quiz that you're going to be looking at is simplifying the radicals. This is where knowing those perfect squares and cubes, writing those from that list that you were to memorize. So this is 26 points. And I often have students say to me, well, you know, if I know I'm just breaking it down, or I'm taking the square root, or I know I'm going to be, show it. If you don't write it down and you put the wrong number by mistake, I have to mark it wrong. I can't give you credit. Even though I might be thinking, you know, I bet they meant the square root of 25 was 5, and instead they put square root 5. It's totally wrong. So show all of your work so that I can give you as many points possible, because it's not a 1-point question when you are looking at those, okay? So when you first ones, if you memorize, those first ones are going to be easy, and even this second part that you are taking a look at here, where you're writing them as a radical expression. Then the next part down after number 12 is going exponential form. So that's where you're writing it like this. So it makes a difference if in number 11, if there's a parenthesis, and in 12 where there's not. Some of you got mixed up when we were doing those kind of questions on your quiz. You sometimes included like the 16 to the half, and it's not going to be, or to the 5th, it's not going to be, right? Just that part is. So being careful in these, if it's underneath, if there's a radical or not. So that's that first page when you were taking a look. Again, you're simplifying these ones and still writing it in radical form. So this is like those first questions. So your answer here is still going to be a root. But you might have a number out in front of that root, right, if you could simplify it. Here again, exponential form. So the first 26 questions are really like, if you think about the test, those are going to be like the first 8 questions on your quiz. Questions 1, as you look through 26, those could be the type of questions you're going to see for converting between the two. Then we go to the simplifying. So we look at questions 27. Here, as you simplify through 35, and then as you are looking at that last page, you have the fractions. Look back at that definition of what it means to be simplified as you are taking a look at those, and then you end with some of the addition and subtraction that we are looking at. While you are working on that, I'm going to play that video, so get started. And we are going to play this video, and we might take a look at one more. And
in today's lesson, we're going to learn about a few careers that you could have where you use radicals and polynomials in everyday life. So a couple of these careers that I thought of right at the top of my head were if you were a doctor or a nurse in the medical field. Doctors and nurses often have to figure out the rates of flow of things, of like bodily fluids, for example, the rate of blood flow, to know how much medication to give you. In this case, the rate of flow is often given in a variable, let's say x cubed per time. Here you have x cubed, so in order to figure out x, you have to take the third radical, the cubic root. Another career that you could have, this one's really fun, is if you were a mad scientist.
And I wouldn't even say it's mad anymore. It's just thinking of all the stuff that
now,
we're doing
I'm sure
with
that mad
space.
Scientists use their brains to solve radicals and polynomials all day. An example here also would be to figure out the volume of a fluid. The volume is given in terms of, let's say, cc's cubed. So here also you would have to take the cubic root of the volume in order to figure out the cc's. So that's the career of a math scientist. Another career where you would use radicals often would be if you were a rocket scientist. Now, a rocket scientist has to figure out the volume of fuel that a rocket would need to fly a certain distance. In this case, once again, you're using fuel. You have a certain volume. You know that the rocket is going to need a certain volume of fuel per time in order to fly. And of course, the volume of fuel is going to depend on the gravitational pull of the planet. So it would be variable as you take off from planet Earth and as you're flying. So this is going to be changing. So in this case, you're actually probably going to be taking radicals with a higher degree. So at least the quadratic root of variables. So there you have it. Those are just a few careers where you would use radicals in everyday career choices, experiments, and such. So thanks for watching. Think about radicals or square roots or cubic roots. I guess you just think of a boring old algebra textbook. But it doesn't really have to be that way. Radicals in everyday life are used, well, every day. So the easiest example of a radical that we can think of in everyday life would be to figure out, for example, the surface area of something. Let's say you're building a shelf. And this shelf is going to look like this, and it's going to have a certain surface area. Now, in order to figure out the length of one side of the shelf, we're going to have to take the square root. So in this case, we're going to take the square root of the surface area. We can make this example slightly more difficult, and let's say we have something with a volume. We'll have a cube. So let's say you want to build a house, for example, and the house is going to have a certain volume. So from this volume, you're going to want to figure out the surface area of the house. So you want to know how tall you can build the ceilings and how big the house is going to be in terms of square footage. So here, we're going to take the cubic root of the volume, and that's going to give us the length of one of these sides. So this side, for example. From there, you can figure out the rest. Now, if we want to get even more complicated, let's say that you're a physician, not a physician, so you have a flow rate through a pipe.
So I think this is where people kind of don't see the big picture sometimes when you're looking at these. By all means, keep working on that assignment as you're looking.
And that's the flow rate of fluid going through this pipe. So, if we want to figure out, for example, how fast the fluid is moving through this pipe in a cross-sectional view, or how fast it's going to take the fluid to go from this part of the pipe to this part of the pipe to this part of the pipe, it's taking it from this three-dimensional view to a two-dimensional view. So there, we're going to have to use a radical once again to figure that out. So finally, I can leave you with this little number, and that is that the radicals are used in everyday life because our cells and everything in nature is pretty much made up with the concept of the Fibonacci sequence, or the golden rule, and that is that everything in life is made up with the 3/4 power rule. And let's make it more applicable by saying, for example, looking either at our veins or the way that trees grow or something like that, or the way that snails lay down shells. When you look at trees, for example, and when a tree grows, here's the tree growing. when it branches from the main trunk here, this is the main trunk, this branch is going to have the volume or the surface area of 3/4 of the main trunk. So if the main trunk has a volume of X, this tree limb is going to be slightly smaller by 1/4 power. So it's going to be X to the 3/4 power. And it's the same if you think about veins, for example. Your main veins that are going from your heart have a very large volume or surface area, and when they branch out into your arms or even smaller to bring blood to your cells, they're going to get smaller and smaller, and every time that they branch out and get smaller, they're going to get smaller with the radical of 3/4. So that's the Fibonacci series. Now you can see that everyday life, the way that we grow, the way that nature behaves, is actually a radical expression. So go out there into nature and think about it. There you have it.